All right, hi guys, this is Ms. Pasenka. We are doing the probability unit, lesson 1. We're working on tree diagrams, counting principle, and factorials. So you guys are going to be able to draw and interpret tree diagrams. You're going to be able to understand and apply fundamental counting principle and use factorial notation. So, I know you guys have been out to restaurants and whatnot, but not during this time, hopefully. So sometimes like at Panera, you could do like a soup, a salad, and a sandwich type thing. So we want to think about how many times could you order a soup, a salad, and a sandwich without repeating the same meal. So obviously there are a lot of options there to do. So we are going to learn about tree diagrams and counting principle here, and then we're going to revisit this problem. So this is where you should write something down on a piece of paper. How to make a tree diagram. If we are given 3 pairs of pants, 2 shirts, and just 3 pairs of pants and 2 shirts, we can make a tree diagram. So what we're going to do is start with a category. It doesn't matter which one you start with. I usually start with the first one that they give us though. So in this case, I would start with the pants. And then you are going to, from each of those branches for the next category, create a branch for each choice. And you're going to repeat that process for all of the categories. So the final amount of branches will tell you how many outcomes you have. Okay? It will make more sense once I start writing it down. So, for example, I'm going to change my color here because that one didn't show up too well. If we have 3 pairs of pants and 2 shirts, so we are going to start with my pants. So I have jeans, I have khakis, and then I also have sweatpants, which all of us have been wearing for these past couple of weeks, right? Then for all of those pants options, I have 2 shirt options. So with my jeans, I can wear my hoodie or I can wear my sweater, and I'm just gonna abbreviate those with an H and an S for these next ones. For the khakis, I can wear a hoodie or a sweater, and then for my sweatpants, I can wear a hoodie and a sweater. Okay, so these guys at the end, that tells me how many options I have. So I have 1, 2, 3, 4, 5, 6 outfit choices. So your answer for this one, outfits, would be 6 outfits. And then the 6 outfits would be a jeans and a hoodie, jeans and a sweater, khakis and a hoodie, khakis and a sweater, sweatpants and a hoodie, or sweatpants and a sweater. So you could do those 6 different options. So that's how you make a tree diagram. Pretty easy. You just start with whichever category you want to. You can also start with the shirt first if you'd like, and you'll get the same outcome. So if I start with the shirt, that would be the hoodie first, and then the sweater. And then from the hoodie, you would have your jeans, you'd have your khakis, and you'd have your sweatpants. From the sweater, you would have your jeans, your khakis, and your sweatpants. So then again, that is still 1, 2, 3, 4, 5, 6 outfits. So either way you do it, you get the same answer. Okay, and that is a tree diagram. So I'm going to give you a couple minutes here to try this one. So you guys are going to draw a tree diagram to show how many sandwiches can be made from the following options. And you can't double the meat or use both condiments. Okay, so pick which one you want to start with, whether that be the bread, the meat, or the condiments. Personally, I always start with the first one that they list because that to me is the easiest, but you guys can choose. So I'll give you a second here to try and set that up. All right, so I don't know if you guys had enough time. If you didn't, just pause it. So I'm going to start with the bread, and that's going to be white or wheat bread. Then for each type of bread, you can do 3 meats. So I'm just going to abbreviate these as H for ham, T for turkey, and R for roast beef. So for my white bread, I can do ham, I can do turkey, or I can do roast beef. Same thing for the wheat. I can do ham, I can do turkey, or I can do roast beef. Give you a second there if you need to write some more stuff down. For the condiments, I'm just gonna abbreviate them. Oh, I can't because they're the same letter. Okay, we'll just write them out. Mustard and mayo. Okay, so for the ham one, you can either use mustard. I'm just gonna do mustard. Must and M for mayo. So I have mustard and mayo for the ham, mustard and mayo for the turkey, and then mustard and mayo for the roast beef. You're going to do the same thing for the wheat sandwiches. So you have mustard and mayo for the ham. You got mustard and mayo for the turkey. And you have mustard, that's getting a little small here, and mayo for the roast beef. So then you can go ahead and count how many end branches you have here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that means I have 12 sandwich options. If you got that one right, good job. As you can see, this can be a lot of work depending on how many options we have. Like if we had white, wheat, and then maybe a pita bread or a flatbread, then we'd have 6 more options to write down. So this, in some cases, can be a lot more work than another way that we're going to learn today. So I already gave you the answer on that, so we'll just skip through this. This was 12 sandwiches. Okay. So for tree diagrams, like I was saying before, it is a great visual, like some of you guys are visual learners, to see how many possibilities exist. But the con, like I just said, it's difficult to draw if there are a lot of categories. So if we had, if we were starting with 6 categories and then each of those categories had another 3 things to do, and then each of those 3 things had another 2, you would have a lot of branches to draw. So we are going to learn something called the fundamental counting principle. Okay, basically, sorry that this is a little blurry, if event M can occur in M ways and it is followed by another event that can occur in another amount of ways, then you have M times N. So basically speaking, this would mean that we are going to multiply the number of choices for each category together. Okay, so get that written down. I'll give you a second here. Or you can pause the video too. So for this example here, if I were to use the fundamental counting principle, let me make sure, we could just take the numbers of each category and just go ahead and multiply them together. So for my bread, I have 2 options, right? That's how many options I have for bread. For my meat, I have ham, turkey, and roast beef, so that's 3. And then for my condiments, I have 2 options. So I'm just going to go ahead and multiply from left to right. 2 times 3 is 6. 6 times 2 is 12. So you get the same answer. You get 12 sandwiches like we did when we did the tree diagram. but this takes a little bit less time. And because there's 3 different categories, we have bread, meat, and condiments, it saves us a little bit time on drawing that tree diagram. So going back to that first problem that I brought up to you guys, how many times could you order a soup, a salad, and a sandwich? So we are going to use the counting principle here. Okay, and basically you're just taking how many options from each group do you have. So for the soups, we have 1, 2, 3, 4, so that would be 4 options times our amount of salads, and we have 1, 2, 3, 4, 5 salad options, times, times our amount of sandwiches, which is 1, 2, 3, 4, 5, 6 options. So we're just going to multiply those together. And 4 times 5 is 20. 20 times 6 would be 120 different meals that you could make here. So say this is from Panera. You could literally go to Panera 120 different times and get a different meal each time, or a different variation of a meal. Obviously, you're going to have to repeat like your soups a few times, or your salads a few times, or your sandwiches a few times. Okay, so you guys go ahead and try these next 2 examples. So we'll go over this first one. I'll give you a minute here to try and do it. So in 1966, one type of Maryland license plate had 2 letters followed by 4 digits. So that means I have 6 spots. 1, 2, 3, 4, 5, 6. Okay, now you need to think about how many letters do I have in the alphabet, and how many digits do I have that are possibilities? Okay, so think about that while you are doing this problem, and I'll give you a second here to work on it. All right, so hopefully you had a second to think about it here. There are 26 letters in the alphabet, and there are 9, 0, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 10 digits to choose from. Okay, it does not say anything about repeating, so that's something that we have to think about. So that means I could have 26 different choices for my first spot, and I can have 26 different choices for that second spot. Then it's followed by 4 digits. So you could have 10 choices for this one, 10 choices for this one, 10 choices for this one, and 10 choices for that one. So obviously this is a pretty big number, but you're just going to multiply those together. And your answer then would be 6,760,000 different license plates that you could choose from. Oh, I totally spelled that wrong. There should be an S. Whoops. Okay, so, and that's something important to look at, is if it doesn't say repeats or it says it can't repeat, then that's a different story. But this one doesn't say that it can or cannot repeat, so we're going to assume that we can. So like, for example, you could have like A, and then 1, 2, 3, 4 as a license plate. Or you could have A, and then like 2, 2, 2, 2. Like, that's a possibility. Okay, so then going on to this one, how many different ways could you choose a sandwich, side dish, and dessert based on the given menu? So this one is a little bit easier because they already give you those options there. So pause it and give it a try. But I'm going to keep going because I think I only can do like 15 minutes of a YouTube video. So I don't really have a lot of time here. So your sandwich options is hamburger, cheeseburger, veggie burger, and PB&J. So that's 4 options there. Then for my side, I have potatoes, beans, and corn, which would be 3 options. And then for my dessert, I have apple crisp, cookies, flan, and cheesecake. So that's 4 options as well. So then you're going to just multiply across. 4 times 3 is 12, and 12 times 4 is 48 different meals that you could make. Okay, so counting principle is clearly a lot easier than the tree diagram. You could easily do this in a tree diagram, but it's going to take a lot more time. So I know you guys probably have posted on Instagram or Facebook or, you know, Snapchat and whatnot, but on Instagram you can have that option to like post your video or post your videos or your photos in a different order. So say you had these 10 photos here, and how many different ways could you upload these on social media? So obviously if you put a photo in one spot, you can't put it in another spot. So that is what we're going to do with this next type of principle here. So we are going to do factorials here with these types of problems. So a factorial is n exclamation point, which is basically just your factorial, and that is broken down into n parentheses n minus 1. So basically, like if you had 5 factorial, you're going to have 5 times 4 times 3 times 2 times 1. Because in each of those spots, once you put it here, you can't put that same thing in that first spot. You're missing one thing. So then you have to go down to 4 and so forth. Let me erase this so you can see that. So you're starting with the first integer or the first number, and you multiply by the next number and so on until you multiply by 1. Multiplying by 1 is always going to be your last step. Some of your cell phones, I think the iPhones, have the factorial operation. If you don't have it on your cell phone, you can use your Wabbit calculator that's on your computer, or if you have one of those, like the calculators that we use at school, they have a factorial on there as well. So then you don't have to go through and keep doing like 10 times 9 times 8 times 7. It will just do it straight away in your calculator for you. I'm sure if you also looked it up on Google, you could do it that way as well. Okay, so how could a factorial be useful? So let's start with the basic one. In how many ways could you order your flour, sugar, and coffee canisters on the kitchen counter? So basically, you have 3 options to put in the first spot. Obviously, you have, you know, your 3 slots here. You're going to have one for one canister, one for another, and one for the last one. So you have 3 choices to choose from for the first spot. You could either do your flour, your sugar, or your coffee. Then I'm going to put my jar, you know, in this spot. So I can't put that same jar in this next spot. So that means I only have 2 jars to choose from. And then I have a jar in the first spot. I have a jar in the second spot. Sorry, those look like houses. So I have 2 jars used, so that means I only have 1 more option to use. Okay, and then so basically you are doing 3 factorial because you have 3 things and you're trying to place those in a certain order. So 3 times 2 times 1 would be 6 different ways that you could arrange your flour, your sugar, and your coffee on the kitchen counter. And the different ways that you could do, oh, I guess it didn't do it. And I cannot go back. So the different ways that you could do on that would be like flour, sugar, coffee, flour, coffee, sugar, and so forth. Okay, so going back to this first problem here, then you have 10 different photos that you want to share. How many different ways could you upload these on social media? So like I said before, we cannot use 2 photos in the same spot. So like I have 10 photos total, right? So for this type of problem, I'm just going to do 10 factorial. I can do 10 photos in the first spot, 9 photos in the second because I already used 1 in this first spot. And I'm not going to have enough room to fit it. 3 times 2 times 1. And when you multiply all those together, it is a huge number. So it is 3,628,800 different ways that you could arrange these photos. So, you know, I know you guys like to get your likes on Instagram. Think about the different ways that you could do this. If you have 3 photos, it's going to be a smaller number, obviously, but the more options you have, the bigger that number grows. So here are some more factorial examples. Okay, now you can do this straight in your calculator, like I said, or you could do it by hand. So like if I did this in my calculator, all I'm going to type in is 8 factorial. If you're doing it in your head or by hand, you do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 40,320. 3 factorial is obviously a little easier because it's smaller, so you could plug it into your calculator with the factorial sign, or you could do 3 times 2 times 1, which is 6. Now, as you can see, the smaller numbers are a lot easier to do, but if we did 12 factorial, that's going to take a lot longer because I have to write 12 different numbers down, or type 12 different numbers into my calculator. So 12 times 11 times 10 times 9 and so forth. I'm not going to write it all down because it's going to take me forever. If I multiply all of those together or do 12 factorial, my answer is 479,001,600. Then for 6 factorial, again, you can just plug it into your calculator if you want, or you could do 6 times 5 and so forth, and that answer would be 720. And then for 10 factorial, again, if you want to write it all out, you can. It's a lot of work to write those bigger numbers out. Obviously, we're not going to give you something like 20 factorial to write out by hand. That one you should definitely do in your calculator. But 10 factorial would be 3,628,800 different ways. Okay, and one thing that I want to remind you is that 0 factorial is 1. Okay, so these ones, I'm just going to run through them really quick. You can try them on your own, pause the video if you'd like, but 4 factorial, obviously you can do 4 times 3 times 2 times 1, and you get 24, or you can plug it into your calculator. Now, 2 and 3 are a little bit different. Okay, so if we have 7 factorial over 4 factorial, you want to think about it like this. So if I have 7 times 6 times 5 times 4 times 3 times 2 times 1, and I have 4 times 3 times 2 times 1. Think about fractions and what we've done in the past. I have a 4 on top and a 4 on the bottom. Those guys can cancel out, and so can the 3's, so can the 2's, so can the 1's. And I'm just working with 7 times 6 times 5 instead. And my answer there would be 210. Okay, so 4 over 4 is just 1, 3 over 3 is just 1, 2 over 2 is 1, 1 over 1 is 1. So those guys can cancel, and we can work with a lot smaller problem there. Same thing with number 3. So this one is a little bit different though, because we have 3 factorial and 7 factorial in the denominator. So I'm going to have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Sorry if that's too small for you. So 3 factorial and 7 factorial have 3, 2, and 1 in it. So this is where you guys might have a little bit of an issue. 7 times 6 times 5 times 4 times 3 times 2, and I'm not going to be able to fit it, times 1. Okay, so basically I can cancel out this whole thing here with my 7 factorial here. Okay, I cannot cancel out the 3 here and the 3 here because I already canceled it out with my 7 factorial here. Okay, and that goes for the 2 and the 1 as well. So basically your new problem would be 10 times 9 times 8 over 3 times 2 times 1. And you would want to either put that in your calculator or just do it by hand. So if I do that, my answer there is 120. Okay, then moving on to the next one. So here are your objectives again. We went through these, we did our tree diagrams, we learned the counting principle, and then we just learned factorial notation. So there are 2 more problems left. Try them on your own before you listen to me go over them, okay? For number 1, you're drawing a tree diagram or you're using the fundamental counting principle. Honestly, fundamental counting principle is a lot quicker, okay? And I'll show you why. So we have this all in a different color for you. So we have 6 different outfits to choose for the body. There are 3 different hats he can tie onto the dog's head and 2 different tail decorations. Okay, so I have 6 outfits. That's my first category. Then I have 3 hats. That's my second category. And then I have 2 tail decorations, which is my last category. So 6 times 3 would be 18, and 18 times 2 would be 36 costumes. Now, I will show you, and I'm not going to be able to fit everything, but we have, 6 different costumes. 1, 2, 3, 4, 5, 6. So I'm going to show you why the fundamental counting principle is a little bit quicker in this situation. So there are my 6 different outfits to choose from. For each outfit, I can do 3 different hats, okay? So I'm just gonna, do 3 lines here. Okay, then for each hat, I can do 2 different tail locations. So for each of these branches here, I'm gonna draw another 2 branches off of that one. So as you can see, that's getting a little time consuming and a lot of work, and I don't have enough room to watch it, or to write it, but there will be 36 different, little branches here in the end. So the counting principle is obviously a lot quicker than the tree diagram, but if you're more a visual person, then go ahead and use that tree diagram. You might just be doing your work for a little bit longer than the rest of us. For number 2, use your factorial. So Bianca has 6 awards that she wants to display on a table for her graduation open house. And how many ways could she line them up on the table? So when you're talking about awards, you obviously can't repeat any. Like you're not going to get the same award every single time. Your awards would say like, okay, if you won MVP 3 years in a row, they're not the same award. They're 3 separate awards. You might have an MVP from, 2015, then 2016, and then 2017. So those are all different awards. So this one would be factorial. So you just have 6 factorial. You'd have 6 awards to choose from for the first spot, 5 awards to choose from the second, 4 for the third, 3 for the fourth, 2 for the fifth, and then 1 for the sixth. And you just multiply those guys together, and you get 720 ways that you could arrange your awards. So if you guys have any questions about anything on this PowerPoint, shoot your teacher an email. And hopefully you guys are all doing well and staying healthy. Today it's snowing in the middle of April, and I'm not super happy about it. Hope you guys are all doing well. Miss you guys a lot. Stay healthy.